Hi, my name is Samuel Mujisha. I am a data scientist specializing in building end-to-end machine learning solutions and helping organizations to make sense from their data. Today, I want to share with you this common problem: forecasting sales revenue through AI-powered insights. This is a very common challenge and business wants to forecast its revenue, and I hope you enjoy and see how it's done using AI. Today, I'll take you through the executive summary, the business problem, the exploratory data analysis results, the model development, the model performance summary, and I'll share with you a demo, a live demo of how it works. I'll finally share my business recommendations. So I have been able to develop and deploy an end-to-end machine learning solution that you could use to forecast sales. The model delivered an R squared, the coefficient of determination of 67%, and a mean absolute percentage error of 18.7%, which means that the model can predict the valuation in the target variable by 67%, and the predictions are off by 18.7% on average, which suggests that our model is quite good, not very strong, but good, and can be used really for this particular case, which is sales forecasting. The model was delivered through a deployable application deployed on Hugging Face, and I will be doing a demo for you later on. So back to the challenge, a very common challenge. Businesses have a lot of data, they have historical data, they have industry trends, and they have data from their sales pipeline. And it's very key to utilize and maximize this data to predict sales on a weekly, monthly, quarterly, or annual basis. This is very, very key to help to make better decisions and to minimize the risk of an inadequate pipeline, making sure the pipelines are healthy and can meet the targets and the sales projections. So let's see how we did this thing. So the goal was really to predict the sales for the product store total sales for the next quarter. We had a data set of 8,763 data records with 12 features. We had the product ID, the product weight, the sugar content in the product allocated area, the product type, the maximum retail type. These are all characteristics about the product. And then we had the other characteristics about the store ID, the store establishment here, the size, the location, city type, and the type of the store, whether it's a departmental store, supermarket type 2, or a food mart. And then the target variable, the product store sales total, which was the target variable that we'll be using. So if you have this kind of data, you can now follow along. So quickly, we did some exploratory data analysis and found that fruits and vegetables and snack foods are the most purchased items. They bring in the most revenue across all stores. Also found that outlet number 4 has the most revenue, the most sales. This is further confirmed by this heat map, which shows clearly that outlet 4 has the highest quantities of sales across all product categories, with fruits and vegetables reaching 700 items were sold across this period. So confirming really the previous analysis. We also found that the product maximum retail price was in the same range across the stores, which is consistent. So we started preparing the data for modeling, and there were a few things that need to be cleaned up here and there. For instance, the sugar content, we had 4 categories: low sugar, regular, reg, and no sugar, so we dropped the reg. In the product ID category, we had to separate the characters from the numbers, and found that actually the characters were used to code the type of products, which was good. I also calculated a store age to do better to deal with age than the years across the data. We had 16 different product types, and we made them 2, perishables and non-perishables, to improve the analysis. And Before beginning modeling, we dropped the features that were not very useful, that we have derived these features, and our data now with 11 columns. So we trained two models, the XGBoost regressor and the random forest regressor. And these were the results. The R squared, the coefficient of determination was 0.67, and the mean absolute percentage error was about 18.7%, which is the same for the XGBoost regressor and the random forest regressor. So we had to move on and do some hyperparameter tuning for both models, and the results were not different at all. They were almost the same, with the 6.7 of the R squared and the mean absolute percentage error of 18.7%. So this is how the results look across the four models before hyperparameter tuning and after hyperparameter tuning, and they were pretty much similar. So we chose the random forest regressor, which had slightly better performance and without the complexity of hyperparameter tuning. So we chose the base random forest regressor. This graph confirms that the R squared is almost similar across the four models, and so is the mean absolute percentage error across all models. So now we saved the model, used Docker for containerization and reproducibility, used Fast REST API for predictions, and Streamlit UI for user interaction. Now I'll show you the demo of how this looks like on the Hugging Face library. So that the application has been developed with a front end that is decoupled from the back end. So the back end is running here separately, waiting for requests, and the front end is developed separately as well. So when we do a prediction, we could see that with these numbers, the predicted total sales for the next quarter, 3430.07 units. If we change the store size again on predict, we get a different number. If we use a different, maybe city type, let me see what to value here. Okay, I'll use the and predict the sales. They're about that figure. So you can play around with this depending on the different product characteristics and different store characteristics and do your predictions. So in terms of business recommendations, quickly, as seen from the exploratory data analysis, it's very important to optimize the revenue based on the product focus. Look at fruits and vegetables and snack foods more. The store size, the store outlet 4, which are medium-sized type 2 in a city of tier 2 was the highest performing, so maybe our expansion strategy could be built on this. And also tier 2 cities tend to have the most revenue, so all these can give an indication of what to do to get more sales. Very important to do dynamic inventory management. Remember, our model is produced an R squared of 6.7 and is off by about 18.7%, a strong model, so you can really rely on this model to plan the stockouts, minimize overstocking, and really optimize procurement and logistics, especially for the perishable goods based on the anticipated sales fluctuations. We decoupled the front end in terms of technology. The front end and the back end are decoupled, which is very key for scalability. The model can scale, handling more requests. For flexibility, you can change something in the back end without affecting the front end, and the code can be used very well and very key for decision support. So really deploying this model on Hugging Face gives a usable interface that users can use from time to time. Further work can be done, for instance, to explore seasonality, holidays, promotional activities, competitor pricing, etc., to see how to improve the model. Thank you very much. I hope you interact with the model. The code is available on GitHub, and that's my link team for questions and answers. But I look forward to working with the organization to build a wonderful sales model that you can rely on to improve the sales and grow sales revenue for your organization. Remember, pipeline is destiny. Thank you very much.